Hello and welcome to this video, and we are going to be learning about absolute error, relative error, precision and accuracy. Hopefully by the end of this video you should be able to understand and define these terms very well to a very good level of proficiency. Now we'll begin with understanding absolute error. What exactly is absolute error? So absolute error. So to understand an absolute error, let me assume that a true value is having a symbol of p, then an let me see, a measured value, okay, is now having a value of p asterisk, for instance. So to calculate the absolute error, first of all I need to determine the error in measuring p. So assuming the error in measuring p is something like this, ep is actually, let me say, true value minus measured value. So this is my p minus p asterisk. Is that okay? So I usually like defining my absolute error, okay, in this particular form. There are different ways to define absolute error. So this is the error. Error is usually the difference between the true value and the measured value. And what exactly is our absolute value? So you just need to encapsulate the error in, the absolute value, mathematical symbol for absolute value, like this, and you get your absolute error. So to do that, our absolute error, I can actually write it like this. My absolute error is equal to true value minus measured value. Is that okay? So some people will take their own like this, measured value minus true value, still the same thing. So another symbol for absolute error, expressing absolute error, is you can use the delta operator, okay. So you can use delta operator. So in delta operator fashion, you can just call it delta p. Is that okay? Let me say delta small letter p is equal to p minus p star, and still the same thing as p star minus p. Is that okay? So this is your absolute value symbol, or you can just use it directly on ep. So absolute value in measuring absolute error, in measuring this particular quantity p is given as the true value minus the measured value. So the definition of absolute error is actually the magnitude of the difference between, absolute error is the magnitude of the difference between the true value of a particular quantity and a measured value of that same quantity. So you're just looking for the magnitude of the difference between the true value and the measured value, because most of the times whenever we take measurements, we will not always get an exact or the true or the actual value of a particular quantity the way it is. Maybe the error might come from the meter rule you're using, or error from parallax, or different sources of errors. There are different sources of errors which I believe you've studied. We have truncation error, rounding of error, machine errors, and so on and so forth. So list them. All those sources of errors can introduce a huge amount of inconsistencies with our work. So it's really good for us to know the absolute errors in some different systems, so that we can be able to implement corrective measures, okay, to correct the nature of whatever we are measuring. So there will be some form of correction. So that's the essence of knowing about absolute error and error in general, so that you can actually introduce corrective measures to your system. Okay, you know about errors, so that when you're measuring, you can actually compensate your measurements by introducing some error factors into the values of your computations. So we've learned about absolute errors. These are different symbols that we are going to be using through the course of this topic. errors in mathematical numerical methods. I love this one, absolute error, although it's long. Some people can use this, some people can use this, whichever one you feel comfortable with using, just go ahead and use it. Now that we've learned about absolute error, let's learn relative error. Relative error. So a better visualization technique to understand error is using relative error. Relative error tells us the significance of an error in a particular measurement. So absolute error tells us the size of the error, but relative error tells us the significance. Is that okay? Please take note of that. So relative error is the significance of the error. So absolute error is the size of the error. So how do you get the significance of the error? Assuming your absolute error, ABS error, was gotten as P asterisk minus P, as the measured value minus the true value, or the true value minus the measured value. I'm not bothered with whichever one I take first, because whether it comes out positive or negative, this absolute value symbol is going to cancel out any sign and just give me the true distance between the measured value and the actual value, or the true value. So this is the measured and this is the true value, true or actual. So the absolute error returns the size of the error, but the relative error, which can be using this symbol E of P, okay, this symbol epsilon, you can calculate it by dividing the absolute error by what? The actual value, okay, which in this case we have P asterisk minus P divided by P is the actual value. Is that okay? So different symbols for relative error. We have RE as relative error, and usually this one over here. So another one which I'm going to show you shortly is, you can use the ratio form of expressing relative error, which is delta P over P. Delta P over P gives us relative error in measuring P, which is the measured value of P minus the actual value of P over the actual value of P. So this is relative error. So any of these symbols, you should be conversant with working with them. They all mean the same thing. So just be flexible. I'm just preparing this video based on your ability to be flexible and based on perhaps the convention you're being taught in your school. So whichever one it is, try to make use of it. The relative error is always going to be the ratio between the absolute error and the actual value. So before I go into accuracy and precision, I'm going to talk about one, which is percentage error. Another way of saying it is percent of error. So percentage error or percent of error is now when you multiply the relative error by 100. So our percentage error in measuring P is 100 multiplied by the relative error in measuring P. Okay, so ERP, or relative. So in other words, I have 100 times delta P over P, which is still the same thing as 100 times P star minus P over P. So this is my percentage error or percent of error. So relative error, one thing you need to know about relative error in contrast to absolute error is that absolute error has a unit. In other words, it has dimensions, but relative error is dimensionless. Of course, this minus this, for instance, if P is in centimeter and if P is in centimeter, you discover that it will cancel out. So if P was in pounds, for instance, and this is also in pounds, this minus this will be in pounds and this will be in pounds, so it will cancel out. So units usually cancel out when you're evaluating relative error. So don't make the mistake, after you finish evaluating your relative error, you put a unit. Relative error is dimensional, it doesn't have a unit, but absolute error usually has a unit. And since relative error does not have a unit and percentage error is derived directly from relative error, so the percentage error does not have any unit apart from percentage. Okay, so we're going to be learning the applications of absolute error and relative error in precision and accuracy. So I'm going to set up a diagram briefly so that I'll explain what this means to us. So try to flow with me. Okay, guys, thank you for hanging on as I did the drawing of this particular analogy. So I want us to understand what precision and accuracy is, and I'm going to use my dartboard to explain what it is. So for each case I have 5 trials. Okay, 5 trials. So I'm going to be throwing the darts 5 times to the board, and this is the target over here. The target is at this point over here. So anybody who can successfully hit the X mark is the winner of my game. But if you don't hit the X mark, I'm sorry, then probably you're not precise, you're not accurate, you're still a novice, and you're still learning how to throw that, or you're still learning how to shoot an arrow. Okay, hopefully you get better. Now let's understand precision and accuracy. So we have 5 trials. Okay, now when we are talking about accuracy, accuracy is a measure of how a calculated value or how a measured value deviates from the actual or the true value. So accuracy just measures the deviation of a particular measured value from the true value. So if I want to talk about accuracy, then I am picturing a value in my mind and I am comparing that value with the true nature of that value. What exactly is the true definition of this value? What is the actual size of this value? What is the actual measurement of this value compared to this one that I've determined, this one I've measured? Do they match? How far do they deviate from each other? So this is accuracy. So accuracy is actually what? Measure of deviation of a measured value from actual value. Now precision, on the other hand, what is precision telling us? So precision is just trying to tell us you can't define precision unless you carry out multiple experiments or multiple trials. That's why initially I said we're going to do 5 trials. So if I carry out 5 trials, precision is just trying to tell me how consistent is the output of these my trials. Do they always give me the same results each time I carry them out? So precision is trying to tell me how consistent a particular value is obtained in several measurements. So that's precision. How consistent is a particular value obtained when I carry out several measurements? I carried out the first measurement and I obtained 18.9. I carried out again, I got 18.9. I carried out again 18.9, 18.9, 18.8, and so on. You discover that this particular value I'm getting after carrying out consistent number of measurements, it's actually very close to each other. So in that case, that value is precise. Now let's use this dart analogy, okay, to understand precision and accuracy. So in the first intersection, I have precise and accurate. So something that is precise and accurate, so probably the first trial got here, second trial got here, the third trial got here, the fourth trial got here, and the fifth trial got here. So everything is kind of like very, very close to the true cycle, and you can see the values, their closeness to each other indicates that they are precise. And remember, the closeness of the values, the closeness of these dots to each other indicates that they are precise. So the fact that these dots are in the circle with the green marker, it means that they are accurate. When let me look at the case of something that is accurate, but not precise. So for it to be accurate and not precise, you will discover that the markers of the darts will be spread, although they will be close to the main value, but they will be spread far away from it. Like they will be spread far away from each other. So this one is precise because they seem more compact than this one. So this one is non-precise, although they are accurate. So being accurate is that these markers are close to our target over here, but for the fact that these markers are kind of like spread from each other, they are not precise. So let's look at something that is inaccurate but precise. So someone that is not experienced at all could be shooting that and he's always getting it at this particular point. So every time he shoots the dart, he's always getting it here. Now all these points that he's getting, they are precise to each other, okay, but they are not accurate because they are far away from the particular measured value. And come to the last one, where we have inaccurate and non-precise. So for inaccurate and non-precise, so I have someone, he shot here his first trial, he shot here in his second trial, he shot here in his third trial, then he managed to hit be harsh. He managed to hit this particular place in his fourth trial. Then the fifth trial, he kind of improved a little and he got a little close, but not so close. So you can see that this last case is inaccurate and non-precise. So non-precise is coming from the fact that the dart markers, they are actually spread from each other. They are spread far away from each other, and inaccurate is that none of them are even very close to the exact value. In fact, the errors is significant, it's visible. So this is just what precision and what accuracy is all about. So the next question you might be, which one is for absolute error and which one applies more to relative error? So I'm going to try to explain that, although we don't really have a fixed convention of which applies to which, because let me start with relative error now. Relative error, sorry about that. I'm writing relative error and I'm making errors in my writing. Okay, that is not so good. So starting with relative error, what does relative error applies to more? Well, relative error applies to accuracy more, okay, more of the time. Relative error applies to accuracy more of the time. So it applies to accuracy more of the time. Now please, there are two types of relative error, okay. So there's a relative error for accuracy and the relative error for precision. So let me explain the relative error for accuracy. The relative error for accuracy that you know is actually the one that I've defined in the earlier parts of this video, where we said relative error is equal to the absolute value or absolute error divided by what actual value. And in this case, what we said was we established that for this particular scenario to be the case, the true value of what we are interested in, of the quantity we are interested in, the true value is known. So in this case, I'll have the approximation minus the true value divided by the true value itself. So this is the true value, P is the true value, and P is the approximation. Okay, approximation or measured value. So this is relative error for accuracy. So relative error for accuracy. So most of the times we use relative error to analyze accuracy, how accurate is a result, because when something is relative, of course you've heard of relative velocity and relative displacement and relative motion and all those kind of stuff. When we're talking about relative motion and relative velocity and all that, we are actually establishing a motion relative to a fixed point, relative to a fixed reference. Now putting it to relative error, our fixed reference is the true value, the exact value of a particular quantity. So if perhaps there is a deviation, so accuracy can best be seen not necessarily by absolute error but by relative error, because relative error actually helps us to visualize error more than absolute error. So absolute error just gives you the size, but relative error gives you the insight. You understand? It gives you the insight of how much that particular error is causing. So let me assume I use a tablet to explain my points, for instance. So this is the true value of a particular measured quantity. Is the true value. Then let's say someone measures a value, and when he measures a value, this is what he now got. He now got the value of his measurement to be a fraction of this particular box over here. So this is the measured, the green is the measured, the white is the true. So what is left over here, this section that is left, is actually our error section. This is the error. So we can call it absolute error, relative error, or whatever we want. But you can see now that this particular place, relative error is going to express this guy in percentage. So relative error is going to convert this particular field to percentage. It's going to give you the percentage of the true value that this error is occupying. Okay, so it's going to give you the percentage. So this is your relative error. So the measured value is resting comfortably at its own place, but the relative error is actually giving us insight to the percentage of the whole measurement, that the percentage of the true value that our error is occupying. So if our error is occupying a huge percentage, then we can know that, wow, this error is really much in the system. So to measure the accuracy of something, most of the times we like employing relative error. So please take note of that. It's usually expressed in percentage as percentage error, percentage relative error, or so on and so forth. So that's about relative error, the first relative error. So the second relative error is precision relative error. So this one is kind of rare, but it's still useful. So we are going to employ it in future lectures, and hopefully I hope you understand it. So precision relative error. So this one comes when someone measures a value. So let's assume when I measure the value, what I now got, my approximate error for measuring that value. So let's say the approximate error for measuring a quantity is given to us as, let me see, x plus or minus delta x. Is that okay? So where this particular guy, x is actually the measured value, then this guy over here is the error introduced by the system. So there are some times that you're not going to be giving the true value. Please take note of that. There are sometimes you're not going to be giving the true value. Sometimes they'll just jump straight to the measurements, that this is what we got after we measure the quantity, the x plus the delta x, as we got, and it became the representation for that system. They'll now ask you to determine the absolute error and the relative error to that system. Now the relative error they're asking you to determine from here is called precision relative error. Meanwhile, this quantity over here is your absolute error, so you don't need to think twice too much. This delta x is your absolute error. So what is your relative error in this case? Relative error for precision in this case will be absolute error divided by this value, this measured value here, x. So the summary is absolute error divided by measured value. Okay, so can you see the slight discrepancy between precision relative error and accuracy relative error? Accuracy relative error is just trying to tell me absolute error divided by actual value, okay, because we know the actual value. But precision relative error is that you're going to be giving a measurement without the actual value. So you're going to use the value of your measured quantity to determine the relative error. Now, when we begin to study error propagation, you're going to understand that we are going to need this particular formula a lot to understand precision, relative error. So relative error applies both to precision and accuracy, but take note, it is used more in determining accuracy than in precision. Okay, so you could actually look up more or read more scripts to understand more about that. So let's jump down to accuracy and absolute error. So absolute error. So finally, so absolute error, this is my handwriting. Absolute error applies more to should we call it precision. So the reason why you can immediately picture this is, remember when we were talking about precision, okay, we're talking about how values actually deviate from each other. Okay, precision is how measured values deviate from each other. So these guys, they are more compact, and these guys, they are kind of well spaced. So you can discover that absolute error will tell us more about precision, because when we start getting different answers and we now consider the differences of these answers from each other, we'll be able to tell are the differences consistent, or I'm actually getting some huge discrepancies between the measurements I'm getting. So just to not say much about it, just know that absolute error applies more to precision, but it is not just limited. You can find some applications of absolute error in analyzing accuracy, but just like I've established, we are talking about which one applies more to which. So absolute error applies more to precision, while relative error applies more to accuracy. So we are going to understand in the next video propagation of errors, after which we'll dive into solving problems on errors, and hopefully you are gonna be all right. So thank you for watching. Like, subscribe, share, hit the notification bell to stay updated on updates, and see you next time.